Hi, algebra class. So today we're going to continue with working with equations and how to solve different types. And today we're going to work equations where a variable or a letter is on both sides of the equal sign. So the very first thing that I have written in the notes, and it is so important, that's why it's bold and kind of in big writing, is it says, after combining like terms, get rid of the smaller amount of x. So is this an absolute thing where like you have to do it, otherwise you won't get the right answer? That's not necessarily the case, but it is the easiest way, and you're less likely to make mistakes when you solve something the easier way. So let's jump right in, and I'm going to show you what that means when you move the value or the x with the smaller value. So here we have 5x plus 2 is equal to 2x plus 14. So notice an x is on both sides of the equal sign. I need to get them on one side. So instead of moving the 5x, I'm going to move the 2x because 2 is smaller than 5, and it's easier to subtract 2 from 5 rather than the other way around. So I'm going to say minus 2x minus 2x. I'm getting my variables together. Now I have 3x plus 2 is equal to 14. I'm going to subtract 2 from both sides at this point because I have all my variables on one side, so now I'm trying to isolate it. Divide by, I'm going to have to rewrite this up here. So now I'm at 3x is equal to 12. I'm going to divide by 3 on both sides, and my final answer is x is equal to 4. All right, let's do that again. Same exact strategy as we used before. So we have 8a minus 5 is equal to 2a plus 19. First, move the 2a because 2 is smaller than 8. So I'm going to subtract 2a from both sides. And I have 6a minus 5 is equal to 19. Now I'm going to add 5 to both sides of the equation because now here's my variable and I want to get rid of this minus 5. So opposite of subtraction is addition. So now I'm at 6a is equal to 24. Finally, divide by 6. And you get a is equal to 4. So it's pretty similar to solving any other type of equation. It's just one of your first objectives is to try to get the variables together on one side and then worry about other stuff. Now, what if you have something where there are parentheses in it, like in this next example? That's okay. You're going to first get rid of the parentheses by using the distributive property and then do everything else that we've been doing. So first, we want to get rid of these parentheses. So I'm going to multiply by 2 over here. Now, this 2 is only next to this set. So this 2 only gets distributed to these two terms. But on the other side of the equation, I have a 3 distributed. So this 3 is going to this set. So make sure you're only giving the number to the set of parentheses that it's next to, okay? So 2 times 5x is 10x minus 2 times 1 is 2 is equal to, then 3 times x is 3x plus 3. So my first step, I distributed. Now these look just like they did before, and I'm going to now try to get my variables all together. So I'm going to subtract 3x from both sides of the equation. And I'm at 7x minus 2 is equal to 3. Then I'm going to add 2 to both sides of the equation because I have 7x is equal to 5. Okay, rewrite what I have. I have 7x is equal to 5. 7 times x is what this means, so I need to do the opposite, which is division. So divide by 7, divide by 7. X is equal to, just leave it as 5/7. There's no need to turn it into a decimal, especially when the fraction is already simplified for us. So notice all we did was we saw the distributive property needed to be done, so we did that first. Then we got our variables together. Then we started isolating the variable by using opposite operations or inverse operations. Okay, so we're going to do that same thing in this example. Send the 4 to this set of parentheses, but we're going to send the 2 to this set of parentheses. So 4 times 3x is 12x. 4 and 1, so I'm going to say minus 4, is equal to 6x minus 26. So this 2 got sent to the 3x, and this 2 got sent to the 13. And remember, I'm just using the sign that I see here, unless it were a negative number. Okay, we're back. I had an issue with the camera. So I distributed the 4, and I distributed the 2. So now we're continuing on, and I want to get my x's together. You're allowed to subtract 12x from both sides. You can do that, but it's easier to subtract 6x. So that's why I'm going to do it this way. But I cannot stress enough, there is more than one way to get to the right solution. So I'm at 6x minus 4 is equal to negative 26. Now I'm going to add 4 to both sides. And I have 6x is equal to negative 22. I'll rewrite that. 6x is equal to negative 22. My last step is to divide by 6. So I have x is equal to, now both of these are even numbers, so I can reduce this, but I'm going to leave it top heavy, and I have negative 11 over 3 for my final answer there. All right, we're getting into a little bit of lengthier problems now, but we still just have distributive property. Then we're going to combine like terms and then get our variables together. So I'm going to go ahead and write that kind of over here to the side. 1, distribute, 2, combine like terms, 3, get variable together, and then the last thing, isolate the variable. So that's basically what we're doing in these next 3 problems. So first I have this 3 and it's multiplied to these things in the parenthesis. So I know I need to do that. And this 3 is multiplied by these guys in this parenthesis. It's not multiplied by the minus 5 because the minus 5 is not in this quantity. So it's only given to these 2 guys. So let's rewrite my problem. I am at 4c plus 3c plus 3 is equal to 6c minus 18 minus 5. All right. Now it's time for me to combine like terms. I'm going to look for like terms on both sides of the equation. Notice how I have a c and a c on the left side. And on the right side, I have plain numbers that I can combine. So this is going to become 4 plus 3 is 7c plus 3 is equal to. I cannot combine this 3 with these guys yet because they're not on the same side of the equal sign. So I have to keep what's on the left side with the left side and what's on the right side with the right side. Now I'm at is equal to 6c minus, oh, I accidentally had something wrong, didn't I? That's a 9, sorry. 3 times 3 is 9. Whew, I'm happy I caught myself. Minus 14. Sorry about that, you guys. All right, now it's time for me to get my variables together. So I'm going to subtract 6c from both sides. And that just leaves me with c plus 3 is equal to negative 14. Subtract 3 from either side. And I'm at c is equal to negative 17. And I'm done. In this next example, I'm distributing once again, and it's okay if you're distributing a fraction. Just think 1/2 of, or whatever is in the parentheses divided by 2. Multiplying by 1/2 and dividing by 2 is the same thing. So those two guys get that 1/2, and these two guys get the 6. So 1/2 times 8x, half of 8x, that's what that means, is 4x, plus half of 18 is 9, plus x is equal to 6 times 1/2 x. Well, what's half of 6? Well, that's 3x, minus, and then 6 times 1, which is 6. So I took care of my distributive property. Now I'm going to combine like terms. Notice on the left side I have a 4x and an x, so I can get those together. I have 5x plus 9 is equal to 3x minus 6. All I did was combine like terms. I didn't change the value of my left side, so that's why I don't have to worry about doing the same thing to both sides of the equation in that step, because combining like terms does not change the value of something. Now I'm able to start moving my variables, so I'm going to subtract 3x from both sides of the equation, and I'm at 2x plus 9 is equal to -6. Don't lose your minus sign because it's in front of the 6. I know that means -6. Then I'm going to subtract 9 from either side. And I have 2x is equal to -15. Divide by 2. X is equal to, I'll just leave it as -15 over 2 because it can't be simplified, unless I decided to make it -7.5, but I'm not going to. All right, we have one more example and then a couple reminders at the end of the notes, and then we are done. So in this example, we have something kind of tricky. This says minus right here. So imagine this as plus a -1, and that -1 is going to be distributed across the parentheses. So that's a little sneaky. So be mindful of those negatives. And on the other side, we have a 4 that's going to be distributed. So let's rewrite this as we distribute everything out. So I have 2. -1 times x is going to be minus x. A negative times a negative is going to get me plus 4. And then I carry down my plus 3x is equal to, now I'm at 8x minus 12. Alrighty, I did my distribution. Now it's time to combine any like terms that I'm able to. On the left side, I have a 2 and a 4 that I can combine, and I have a -x and a positive 3x. So I have 2x plus 6 is equal to 8x minus 12. Okay, now notice I have a variable on both sides of the equation, so I'm going to take this 2x because it's the smaller number and subtract it and get it to the other side. So I'm going to say minus 2x from both sides of the equation, and I'm at 6 is equal to 6x minus 12. Now that all my variables are on one side of the equation, I'm going to start isolating them. So I'm going to add 12 to both sides. I have 18 is equal to 6x. Divide by 6, x is equal to 3. Alrighty. So these are the longest types of examples we're going to do today, but I just have a couple reminders where if you keep these in mind, these rules that I'm about to talk to you, you should be just fine. You just have to keep applying them each time because these are rules that you don't ever break, and as long as you follow them, you should be all right. So remember, what you do to one side of the equation, you must do to the other. Note, only when it changes the value. So if you're taking away something, if you're adding something new, that's when you have to do the same thing to both sides of the equation. If you're rewriting it, if you're reorganizing it, that's different. Next, in order to isolate the variable, you must use opposite operations to isolate the variable. This is key. So if you remember these two things, you should be doing pretty okay with solving multi-step equations and equations where the variable is on both sides of the equal sign.